Alright, so here we are with our 4-2 notes. We're talking about inverses of relations and functions. So, an inverse function is something that represents the opposite operation. So, we're thinking of, for instance, the opposite of division is multiplication, opposite of addition is subtraction, that kind of thing. And the x and y switch, if it's in a table, when we're talking about a function here. And the graph reflects over the line y equals x, which is a diagonal. So, taking a look at what we have here, if I'm going to graph this equation here, which is an exponential looking graph, if I had the points for that, which I don't actually have, these are not the points for this graph, all I need to do in order to get the new graph is to take your x's and make them the list of the y's. So for instance, -4 would actually be my x, -2, 0, 2, 4, 6, and 8. After that, if I want to then say what my new y values are, my y values are going to be all of what used to be the x values. Alright, so that's just how it is with a graph. And again, these are all completely different functions that we're looking at. So, then if we want to talk about this graph here, again, you're flipping the x's and y's. So, if you're going to graph this on this reflection, the idea is that this and this are going to flip with this to this. So that line that's there that came through very close and then intercepted here, and actually this point right here is 0, 1. Well, if we're going to put that onto our new graph, that's going to be 1, 0, right? Because we're flipping it. So it's going to kind of come in away from the graph here, just as this one did. And then it's going to cross, but then not actually get to 0, right? Because this is an asymptote, and then go through here. So, without all of these pieces here, this going through 1, 0 is the inverse function of this one. You'll also notice as we looked in our notation that this, with this tiny little 1 here, is actually how you denote an inverse function. So for instance, I would say this one is f of x, but I would say that this one is f of x with a tiny little -1 in there. That's to indicate it had to do with f, the function originally, but it's its inverse. So, interesting notation. The next piece is the equation, okay? And so the process for the inverse is the fact that we take your f of x and make it into a y. It's a lot easier to do the x's and y's if it's y equals. So I would rewrite this as y equals 2x plus 3. Then, as we kind of mentioned here, the x and y switch. And so we're going to exchange the x and the y. And so it becomes x equals 2y plus 3. Then we're going to use SADMEP, which is the order of operations backwards. So subtraction and addition would be first, then division and multiplication, then exponents, and then powers, or sorry, parentheses. And so I'm going to do the opposite of adding, which is subtracting first, giving me x minus 3 equals 2y. And then I'll do the opposite of multiplying, which is dividing. And so my ending equation is x minus 3 over 2 equals y. And then we exchange y with f inverse of x. Because now we can say that that is the inverse equation. So 3 ways of looking at an inverse. You've got a table. All you do is switch the x's and y's. A graph, you reflect over this y equals x line. And an equation, you switch the x and y and solve so that you get the y all by itself again. Which, as you look at it, notice that this has a plus 3 and a times 2. And this final has a divide by 2 and a minus 3. So we are talking about these opposite operations when it comes to your inverses. So that's the basics, and so in your assignment you're going to do a few of these to kind of practice these 3 techniques of tables, graphs, and equations and making them into inverses.